good morning or good afternoon, depending on where you are joining us from. Thank you so much for finding time in your busy schedule to attend this free webinar hosted by the International Institute for Software Testing, the leader in software testing training and certifications. We would hope that you will always join us in our free webinars. You can always see the schedule on the website at testinginstitute.com. I'm very pleased to have with me today Mr. Bhushan Gupta, who is the leading consultant at Gupta Consulting, a company in Portland, Oregon, that's providing training and consulting in different areas of web security and application security. Mr. Gupta has extensive experience in many fields of software engineering, agile, and security. He's a leader of the OWASP, the Open Web Application Security, the Portland chapter. He's also a certified Six Sigma Black Belt. Mr. Gupta has been a faculty member of the Oregon Institute of Technology in the software engineering department, and he has been speaking at different conferences. I have heard Mr. Gupta speaking a couple of times, and that's why I wanted to invite him to do this webinar for IIST. With that being said, I'd like to give the microphone to Mr. Gupta. Bhushan?
Thank you, Dr. Hanna, for a nice introduction. Good morning, everyone. And again, thank you for taking time from your busy schedule. I would like to share some things with you, and hopefully you can take them back to your work and apply in your day-to-day life. Dr. Hanna has said enough about my introduction. I'm going to go ahead and start with my presentation. Okay, just a couple more things about me. I'm a vegetarian. I like to be vegetarian. Grew up as a vegetarian. Sometimes I don't mind eating something that swims, like a fish. I am a tea lover. I just have a knack for the tea, and I really enjoy that. I call myself a quality champion. I spend a lot of time dealing with quality, very early stages of software quality or quality engineering. I was with Hewlett-Packard for a long time, and then I spent some time at Nike. And I try to share my experiences as I feel that they can be helpful to people. I presented really vastly, and it really gives me a great satisfaction to share my understanding and my knowledge with others. With that, let's go ahead and talk about those of you who are here. I'm assuming you're security professionals. And if you're a security professional, you may be a hacker, spending all your time trying to find out how you can hack a web application and steal information, or just for the fun of it, just lock somebody up. Okay. You may be a security cop. Your job in that case is that nobody comes around and cause problems for your web application, which is running smoothly. Or you may be a developer thinking about how do I make my code secure. You could also be a tester to make sure that your code is all secure. There is a little bit of a combination here. This talk is mainly for those who are involved with security testing, but there are also some nuggets here for those who are developers. Okay. I'm going to take you through the objectives I have this morning for us. First of all, I want to show you that there are no breach patterns. There are no breach patterns. Then we will look at how you can really ingrain security into your development life cycle, whether it's waterfall or it's agile. I'm going to mostly talk about agile. Then I will show you how you can conduct a multi-stage testing, meaning the testing at all levels of your development, and what the rewards of doing that are in a secure life cycle. Just to give you a quick picture, and this slide may be a little bit dated, but the trend is still the same. In middle of 2019, we had far exceeded the total number of breaches we had in 2018. So that's how big the problem has been. It hasn't improved yet. You may have heard about the pipeline that got hijacked for a ransomware, and they're still trying to recover from it. It causes havoc in the society. And the problems are everywhere. Banking is mainly focused because of financial gains. Then there is also healthcare industry impacted by it because people try to steal personal information from others. Ransomware, I just gave an example of ransomware, is continuous. It gets worse if the old people are held for ransomware. And last but not least, government. We just had a big breach in US government. Different agencies were impacted. So the problem is not getting any better, it's only getting worse. Now, let me establish the fact that there are no patterns to it. So if there is a hacker, there are several ways they can hack your web application. I'm going to give you 4 examples which would prove that there are no unique way to hack an application. So let's start with Facebook. Facebook was hacked, and it was hacked by stolen user access token. What that basically means is that if you are on Facebook and if you want to stay on Facebook for an extended period of time, you don't want to log out, then you are given an access token which you can use over and over again. And that access token is sent to you whenever you are ready to go back to the application. And in this particular case, that access token was stolen by a hacker, and that access token gave access to the hacker to Facebook APIs. And that was the way the Facebook was hacked. Let's take another example. This is from a European bank, European Central Bank. And European Central Bank was hacked by a malware injection. The malware injection was not in the code of European Central Bank. It was in a third-party application which European Central Bank was using. So this is a way, another way somebody can hack a web application. Let's go to number 3 here. This is First American Home Buyers Protection Corporation, and they were hacked by parameter tampering. So those of you who know about parameter tampering, when you type a URL and when you're doing a query, the query itself gets attached to the top URL there. And then with that, by making the change to that URL, you can gain insight into the website. You can even make changes to where the query is going. And that's how First American Home Buyers Protection Corporation was hacked. Okay. Last but not least is Disney. Disney was hacked, or Disney Plus was hacked by credential stuffing. Now, what that basically means is that Disney was hacked earlier on, and the information was available on dark web. People took that information and they started stuffing the credentials. Just keep on trying until they hit the right one. Disney Plus was hacked in that way. Now, you will agree with me that there are no breach patterns here. There is no one or more subtle ways a breach can happen. They can happen in multiple ways. If that is the case, we need to know some more about the life cycle of a breach, or how the breach really impacts us. So first of all, in this particular graph, what I'm showing here is there is X number of days before a breach gets announced to the public. Mean days is 197. You may call it average days. 197 0 days. So you don't know about the breach, or the company doesn't announce a breach for 197 days. Then the 0 day comes along, and then everybody knows that there is a problem or there's a vulnerability in the application, and it takes about 69 days to contain it. So overall, a breach lasts for 266 days. What we also need to realize here is that once the vulnerability is public, there is more temptation to breach that web application. What you can do is shut down your application until you get to the containment, which costs money. It also costs customer loyalty. People may not want to come back to your website. And I had done that in my particular case with Home Depot when Home Depot got breached about 5-6 years ago. And then you have to deal with litigations, which are expensive. So having a breach or having a vulnerability exploited is not a cheap thing. It costs you in terms of money, customer loyalty, and the litigations to deal with. Having established that, one more fact we should know, and you should all know that because this has been there forever. Whenever, like a defect, whenever there's a vulnerability, it costs a lot more when you have, after you've deployed the product and you're trying to take care of it, as opposed to when you look carefully while you are building the application in different phases, such as design and development. So the cost of handling a vulnerability really increases as you move into the development of the product, which is not a surprise to anyone, shouldn't be. Okay. How have we been fighting it? Our main approach has been penetration testing. So penetration testing is when we try to take some scenarios and we try to test our application against those scenarios. Those are limited scenarios. People look for some low-hanging fruits at times. Sometimes they look for things which have been proven to be causing a breach in the past. There are some characteristics of penetration testing. It's an art of finding known vulnerabilities, something which we know about. For example, SQL injection or man-in-the-middle attack, those are the ones we try to look for. In other words, we are not thorough. We're just looking for the vulnerabilities that already have been found in the field. It does very well. Penetration does very well for networks and operating systems. It really, you can go through the network and operating system vulnerabilities and check them out properly, and it does serve very well for you. Okay. One of the problems is that we have tools for penetration testing, but their effectiveness is limited. So you can't really always guarantee that you have tested everything if you have done penetration testing. Okay. Well, how do we do that? How do we get to a better state? We can do that by applying the testing techniques all through the life cycle. The emphasis here is that when you do penetration testing, it's always at the very end. So making any changes becomes more and more expensive. That is why we try to do things early and more often. And that's the message here. Do things early and more often. And to me, penetration testing is like checking for COVID systems. Are you coughing? Do you have fever? And if you don't, everything is good. But later on down the road, you find out that somebody has really been impacted. So penetration testing is looking for some symptoms, right? Here is a famous quote by Gary McGraw. Gary McGraw is a well-known security expert. And what he's saying is, and I'm going to read it for you, if you fail a penetration test, you know you have a very bad problem indeed if you fail the test. But if you pass the penetration test, you don't know that you don't have a very bad problem. So passing a penetration test does not guarantee that you do not have a bad problem. You do not have a severe vulnerability in your application. Okay. What are we going to do? If you really want to have a high level of confidence in your web application, you have to take a proactive approach throughout the life cycle. Okay. And I'm going to show you how it is done. Okay. Before I do that, let me tell you why we should do that. First of all, as I just told you, it takes a long time to contain a breach. Second of all, it costs a lot more when you try to contain a breach after you've deployed the product. And developers not just make mistakes, they repeat mistakes. Maybe your developers are a lot smarter than that, but commonly developers repeat mistakes. You have open source dependencies. You don't know how good the open source is. Most of the time, it's not really kept up to date. And then you have outsourced dependencies. You may have third-party applications that you're using or components that you're using to build your application, and that may have vulnerabilities. I give an example of that when we were discussing Central European Bank. Okay. So let me go over some testing strategy here, which you probably all know, but just to refresh your thinking here, we want to test often and test throughout the life cycle. If you really want to have a high confidence application, whether it's usability, whether it's functionality, whether it's security, you want to have often testing, you want to have testing often and throughout the life cycle. You want to have all stages of testing. In the security world, we call them blue team, red team, and purple team. Red team is actually the QA team, blue team is the development team, and purple team is when they come together and test an application for security. We have also have similar stages we call glass box, gray box, and black box testing. So they really map, the team names map to the strategy we use in testing in general. Now, there is lots of tools available for everything in our discipline. I can tell you, just for security, you have 52 different tools available to you, which are open source. You don't even have to pay for it. So now if you have so many tools available, which one do you choose? Whichever you choose, make sure it's appropriate for your use. And always try to test for known vulnerabilities. So in our strategy, we will first try to test a known vulnerability. If we are aware of it, people are writing code, they know this code is weak, so let's make sure this code is tested thoroughly. And also, just like high severe defects, same thing applies to your vulnerabilities as well. As soon as you find a high vulnerability, report it. Okay. We always need to pay attention to third-party and open source code. So these are the guidelines or some key drivers for testing the web application. Right? I'm going to give you two scenarios here. One is early in the life cycle. The later one, or the second one, is a little bit later in the life cycle. So let's look at the code state. So when your code state is raw, you have source code. You may even have object code. The type of testing we apply there is review techniques, where we look for design and coding security risks. Okay. It's mainly review techniques. There are some tools there, and we call it static application security testing, or SAST, fairly well-known terminology in security world. So this is what we do when the code is raw. When the code is Executable, at that point, we do a variety of things. We do a quick assessment of where we are in terms of security using some scanners. Okay? Then we need to do formal security depending upon the security controls we have provided into our web application. And then we also do penetration testing, which is thinking like a hacker would think. Okay. Let's look at when the code state is raw, what can you focus on? What is that you can test in that area? First of all, very simple thing would be you look at your development environment. If you have an operating system which has known vulnerabilities, you have a language which has known vulnerabilities, you look at those particular things. So for example, if you look at operating system, buffer management would be one thing where you can identify buffer overflows. Buffer overflows can cause a hack in the system. Somebody can write the code in an overflow and hack the system. You also look at algorithms. Am I using the right algorithm? For example, if you were going to go and use a encryption algorithm, you want to see, you want to make sure that you have the right algorithm, or this is how the algorithm is going to work for you. And you also look for business logic. So those are the things you can look in early stages in the development environment. The other thing you can see is the access rights. Have you given proper access rights to the user? You don't want to give admin access rights. You all know that. We don't want to do that. But you want to make sure that we don't give admin rights when general user has to have just basic rights. And then is there a possibility that a escalation or elevation of privilege can happen? So these are basic things you can test while you are in the early stage of the code. Coding practice. Look at input hiding, very, very important. Today, whenever you put in your password, it's always hidden unless you want to see it. If you look at social engineering where somebody is looking over your shoulder, what you're typing as your credentials, that could be hazardous. So input hiding really saves you from that. Okay. I mentioned a transport layer protocol. Am I using the right protocol at this point? Is it the secure protocol I should be using? You can easily check for that. Testing something like that would be very, very difficult. Okay. Use of prepared statements. Now, those of you who are familiar with SQL injection, the way SQL injection happens is when you take the input from the user and build a SQL query. And then there is room for somebody to build a SQL query which can serve as a credential without any checking. So that is why we try to use prepared statements where the query is built excuse me, from the data somebody is sending, but only the variable values and no more than that. Then you can look for runtime environment. Now, if you look at different components you're using, some of the components may already have some default configurations which may not be right for you. It may have high level of privileges for a general user. That's what access rights are all about. You may even have some third-party apps on which you don't need. And the worst case scenario is if you leave the debug statements in your code, they give the hacker a way to find out what your environment is, what your platform is, and if they have that, then they can use known vulnerabilities to breach your system. This is the state when your code is raw. Excuse me. Why do we use? There are some tools for that. They're not very widely available. There's only a few, but they scale well, and they are faster than a human. They could do the work of reviewing faster than a human being can do. And then you know that you need an expert to do reviews, no matter what kind of review you're doing. Some tools really can pinpoint where the vulnerabilities are. These tools also have some shortcomings. First of all, they give you high number of false positives. Now, somebody might say, oh, false positives, I really don't care. But if you have a false positive, you would go back, you would log that as a vulnerability, and then you will go back and try to fix it, which wastes time. So false positives are equally bad. They're not as bad as false negatives, but false positives are equally bad. They don't give you a comprehensive picture. They cannot test everything. Those tools cannot really test everything. Some of those tools are SonarQube. SonarQube is open source, provided by OWASP, and there is also 45, which is from HP. So there are some tools available which you can use. They have not been really, SAST is fairly new technique, and there hasn't been much done in this area. Okay. So let's look at executable code. We call it dynamic application security testing, and we start with code scanning. That would be the first step. We would do preliminary testing of your application. Whenever we get this, when we get this information, that would help us to enhance our formal QA testing against the acceptance criteria, which is very widely used, which I consider the backbone of Agile development. And like I said before, we test like a hacker. So this is the chain we go through when we are doing a DAST in an executable code condition. Okay, so code scanning, very early assessment of the code you have to do. You want to do. Type of things you can do with this, like web spidering, where you can see if there are any broken links or there are links going outside of your domain. Look for those things. You can do SQL injection type things using web scanning. Some fuzzing, where you can provide the data or vary the data for testing, and you can also look at parameter testing. These are all built-in features a scanner will provide to you. The strengths, it can quickly simulate a malicious user. They build the tools in a way that they would simulate all potential vulnerabilities. They're language independent. You don't need to worry about whether you use Python or you use JavaScript or anything like that. They're language independent, and they give you a good initial assessment. You would know how good am I at this point when I'm using, how good is the quality of my code in terms of security at this point. And then information would then help you improve your further testing. So those are some good things about your code scanners. They don't test everything. They can only test things which they are designed for. These tests are predefined, and they can test those. Again, you get false positives, and there are times when tools may be outdated. An example of that tool would be ZAP. 45 again is an HP product, and they also have a very good product which gives you nice summary of where the problems would be. ZAP is very popular all over the world. It's put together by OWASP, and most people use it because it's easy to use, and it also is interactive. So is 45. So this is what you do when you are in the later stage of the code. Okay. Now, how do I do proactive security testing? First of all, you need to create security stories, and I'll show you how to create security stories. Then once you have a security story, then you would want to create a acceptance criteria. How, under what conditions, under what criteria this story will pass. Okay? Then now we know what is required of this story, then we establish some security controls. And from those security controls, we drive our test cases. Okay? So put that in perspective with Agile development. You have so many different phases of Agile development that are going through here. First of all, sorry about that. You need to have in your backlog, you need to include security stories. We don't do that today, but it's important that you think through security stories when you're thinking of functionality, when you think of usability, when you think of performance, you also think about security. It's a component of your quality attributes. Okay. Now, you go through the whole process you will otherwise. Develop acceptance criteria, define controls, like I said, and plan security validation. And you will go do that in all the phases. When you're developing code, you will test, you would validate this to it like you will do any other QA testing. And then over on, when you're validating the system, you will validate for security as well at that point. Okay. Now, how do I really identify the stories? So there are actors here. There are different types of users of your system, and hacker is one of the actors. And from hacker's perspective, a story would be set the shopping cart total to 0. I want to, as a hacker, I want to buy everything, but I don't want to pay for it. So that would be a typical story for a hacker. There'll be more of certain nature depending upon how deep you want to go into your system. And you should look at every possible ways a hacker can go into the hack your system. Okay. The customer stories. The customer story would be protect my personal information. I'm providing you my credit card information, so protect that. So that would be the hacker story. And then if you're a developer, you will have a story which will look like no one should be able to force privilege escalation. Okay? If your credentials are set for general user, you shouldn't be able to escalate those to an admin level. And a security engineer will have a story of his or her own, and that would be something like website should be up during business hours. So for example, DDoS attacks are taken care under that story. So for different users or for different actors in your system, you can come up with the stories which then you can take it through the normal process of story development. So let's look at customer story. How do we develop this story? And the story is, as a user, my personal information is protected and not exposed to others. Okay? And there are other conditions to this story. Those conditions are, it should not be exposed at entry. When I'm entering the data on the client side, my user information should be protected. When the information is moving from the client side to the server side, it should be protected. And when it's stationary on the server side, it should be protected in that condition as well. So my information is protected at the entry, in transit, and when it's in the database. Okay, this is the story. Now, how do we build acceptance criteria? This is how we do it. On the client side, hide my data entry. Very simple. Hide the entry. If I'm using my password, hide that. If you're asking me for some other credential type information, hide that. Do not expose that. And we are very good at this. At this point, we are really good at hiding data at the entry point. When I'm transiting the data, and the data is moving on the line, on the wire, maintain my data confidentiality. I don't want it to be exposed when the data is moving on the line. And then when I'm on the other side, on the server side, my data should be accurate and integrity should be maintained, meaning that nobody who is not authorized to manipulate my data should be manipulating my data. It could be processes, it could be a person, it could be an admin, it could be some process which writes the data of the database. Not an unauthorized process should be able to change my data. Okay, and only authorized access should be available. This kind of 2 and 3 are kind of a little bit overlapping, but nobody should be able to have access to my data other than the authorized user or the authorized process. So now we have an acceptance criteria for protecting user information. All right. So how do we build the controls? How do we build the checks and balances? So the way that we will build all the control, security controls, would be do not display critical data. That is the security control. And then when we come to passing the data or transmitting the data, at that point, we should send the data on a secured socket layer. Okay? And then the data should be encrypted. So for that data, I have 2 requirements or 2 security controls which should be met, which are secure socket layer, SSL, and encryption. So a user or a developer will then think about, okay, so which transport layer should I use and which encrypted algorithm should I use? Yeah. And when we get to the other side, we can say validate data before storage. And again, before we put the data in the storage, encrypt it, and then we make sure that to access the data, only we provide least level of privilege. We will be maybe view only, nothing more than that. So this is how you put your security controls together. Okay? This is one example for this particular story. Now, the other thing I want to expose you to is not every story is equally vulnerable. How do we decide that? There's a technique developed a while ago by Microsoft. They call it stride, and it has been emphasized over and over again. It's basically what we try and do here with this technique is trying to see what the threat is to your application or to your story. In this particular case, the way we should do this modeling should be agile, should be quick, and let the engineers do it. So I'm going to show you how you can do it fairly quickly without much effort. Just to explain what stride is, it consists of 6 different pieces. First is spoofing. Spoofing is like social engineering, somebody gaining access to your system using false entity. Okay, when you get an email, it has a link from someone, and you click on the link, and then somebody gains access to the system which is not authorized. Okay, tampering, unauthorized modification of the data. Somebody goes in there and tampers with data. Repudiation is important for legal purposes. If somebody hacks my system, I should be able to prove that this person has really hacked the system. In other words, the code should support repudiation, and the private data should stay private. Information disclosures should be maintained. We talked about denial of service, where your website cannot be accessed. And I have talked about elevation of privileges. So stride is made of these 6 items. Now let's apply that to a particular, or to a few stories. So the stories are very generic in this particular case. A story could be you're just browsing a website. Okay? You're not doing anything. The website is just literally not asking for any information from you. whenever second story is you're creating user profile and you need to have your account set up. Then you are creating login ID, password, and login. So basically what I'm showing you here is a sequence of actions that you would take to be part of a web application. And if you apply that technique we just talked about, you can get a score on different stories. In this particular case, login is the most vulnerable activity. See? A score with a score of 5. This way you can really go through your stories and prioritize them based upon the vulnerability you will have for a story. You can choose any other technique you want, but simpler techniques are better techniques. Okay. So we briefly talked about that, and I don't think we need to go over it a whole lot. And basically is saying that all through this life cycle you should make an effort that you test often, you test early. SAST, DAST, bear in mind DAST is you're doing scanning and you're also doing QA, followed with penetration testing. Okay. All right, so let's go over these techniques, especially in all SAST and DST. So first I talked about code review. What can you do with code reviews? You can look at a development environment. We talked about things like buffer overflow. You can look at your algorithms, and you can also enforce coding standards by doing code reviews. 2 things I told you is it needs expertise. Somebody should know things inside and out, and it's time consuming. And that's why we kind of take a different approach, or a little bit more fast approach to it, which is using a tool for the same purpose. And what you can see, you cannot see everything you can see while doing code reviews, but you can see certain things to give you some confidence and a quick assessment of where you are in terms of certain vulnerabilities. So combination of those two could be very good. Excuse me. Combination of those two would be very good. We talked about false outcome, and there's a maintenance cost. There's also a tool cost associated with it. Okay. Formal QA, I talked about the acceptance criteria. I talked about security controls, and this is how you drive your test cases and test plans. If you're using a tool, they will find tools would be like scanners. They would find common vulnerabilities for you, and then to enhance your process, you will do a testing against acceptance criteria, which we always do in an Agile development. Again, there's tool cost and maintenance involved. At the end, we do penetration testing, and we test like a hacker for targeting vulnerabilities, which we are well aware of that they can happen, or vulnerabilities that hackers exploit to get into your system. The other thing I have here is system hardening, and system hardening is when you make sure that your configuration is set the way you want. I gave you an example where you may have a web component which has default settings. You may want to make sure those default settings are not default anymore, they're customized for you. Access privileges, your environment, and things like that. Okay. Now, this is how you're going to proceed with security validation. It's a combination of things. It's proactive, it's exhaustive, and that's what gives you a high confidence web application. Okay. This is a chaining method. We're taking code reviews, whatever we find from code review, we try to see if we can see them in SAST, and whatever we get from SAST, whatever we are seeing in SAST and code reviews, we make sure that data are handled in our formal testing as well. We want to make sure that we eliminated what we have found before as we move from stage to stage. And here is our penetration testing at the very end to get the product the way we want. Okay, now let's map it up. Let's map it all up onto the agile development. So we have security in the items here, backlog, we have security stories. From the security stories, we have developed security controls and security. We have assessed the risk based upon stride. Once we have that, that would give us a way to put together our test cases and also a test plan. Okay. Then when we go to the next stage where we're trying to build the code, we do code reviews and we use whatever tools is appropriate for us to automate that code review process, okay, so that we can get a quicker response or a quicker assessment of where we are in our vulnerability state or how vulnerable we are. Then we go through DAST, which is pre-scanning. This pre-scanning, we have seen through, or we have looked at some very common generic vulnerabilities, and we have made sure that they don't exist. After we have gone through that, we look at our actual QA red team testing, where we have executed the test cases which we have planned for, and we now know where we are in terms of security assessment. Okay, this is how you will take in the whole iteration. This is how you would go through different steps, and then at the very end you will do penetration testing for overall evaluation of your system for the common vulnerabilities, making sure that they don't exist. Okay. This is how we proactively approach how to test for security testing, or how to test for security. Okay, here's a different view of this. Same things, but in different ways. Remember when we were talking about a hacker does not want to pay for what the hacker has purchased? That's an abuse case. Okay, when we developed acceptance criteria, security controls, those are your system requirements, security requirements. That's what gives you the actual security functional type or security stories. Then I talked about stride. You can do that risk analysis with respect to security prior to designing, after designing. After designing will be things like, okay, does my encryption algorithm works properly, or is it the right encryption algorithm I should use, or is this the right transport layer I should use? So those would be the things to consider. You can always have an external review. An external review would be if you have a security engineer, or you have your customer has a security group and they want to really bring that person in, you can have external review from that person. And then when we are in the testing phase, or not, before coding, we try to do our early testing, code reviews, SAST type testing mentioned here, risk analysis again based upon those test results, and then we do formal testing followed by penetration testing. Now, And when we've gone through all this, we want to make sure that we have some mitigation plan, just in case things break, bad things can happen. For that, we need to have a risk mitigation plan. Okay, how do we balance this art of the risk here? The best thing is, in an iteration, you compare your stories and then prioritize them based upon their stride score. Okay? So you take whatever your capacity is, take those top score stride stories, and you build those in an iteration. Now, when you move to the next iteration, you will do the same process on the new stories, and you will have a stride score one more time. Now, when you have the second set of stride score, you again prioritize based upon the highest or higher score between the two iterations. So you are always paying attention to the highest or the higher stride score stories. That's how you would balance your risk. And when you're testing the stories according to the score. It would be wasting your time if you're paying a lot of attention to the stories which have low stride score. All right. As I mentioned before, you have a big picture, a good picture of where the risks are, and make sure you have a risk mitigation plan. Okay. Let me go over the benefits of this methodology here. First of all, we are pushing security up towards engineers that are involved. They're involved in acceptance criteria. They are very much involved in security controls, because these are the people who know how to make something secure, and they are paying attention to security controls with collaboration with the security engineer and the test engineers. So we're pushing security up towards engineers. Each story you are developing has gone through a risk assessment. We have looked at every single story and saw or calculated what the stride score is and how much risk do we have on this story. Okay. We are paying due attention to the stories with high risk. And that's how our balancing act is taking place, always paying attention to the high risk stories. And we are not testing a story just for testing for the sake of it. We are testing stories against the security controls. If we didn't have the security controls, we will be just testing, how would the hacker get into this code? But now we really are focused on security controls and trying to figure out those security controls are well implemented. Development is efficient because we are testing early using SAST code reviews, and then we are testing with DAST. I do not want to undermine the value of DAST. These are scanners. These scanners give you a good assessment of your vulnerability levels. Okay. And then we finally are using pen testing to confirm any external threats we may have from the hackers. Okay. And we also have a mitigation plan so that if things go wrong, we know how to handle them. The study shows that if you just had a mitigation plan, you will have a very high return on that plan. I think it could be anywhere from $1 million to $6 million depending upon the hack. So a mitigation plan always helps. Excuse me. All right, so let me give you some thoughts, some more things to think about. Liz Rice is a technology evangelist. She's very much into security. And here is her saying, and I'm going to read it to you. If you can push security as far as you can to our developers, it's a good thing because you can catch problems earlier. Dependency graph can shift security very far left. And what I've given you is just the way, the technique to how do you shift that security aspect up towards the developers. Manako is well known for security. He now has his own security consulting. He says software engineers are security engineers. Think about the security controls, data hiding, credential hiding, which encryption algorithm to use, what should be my transport layer. Who would know them better than the security engineers? So those are the best people which can help a QA team or even a network or a security engineer to not just implement but also validate overall security of your web application. Think about Purple Team. Purple Team is made up of developer, a security engineer, and test engineers. When you bring them together, you're bringing all the power together to judge or to really establish the security requirement, how to test them, and here is how, and then test them the way you need to test them. I think these are very good words. These are the things which we can learn from. And that's all I have. Dr. Hamana.
Okay, good. Thank you so much. I was just about looking at the clock. We have 3 minutes left to entertain some of the questions from the audience. And if you still have questions, please go ahead and click on the questions tab and write your question quick. I have a few questions here that have been submitted so far. First question, someone says, we are using a security scanner called ZAP. Do you think those security scanners are enough to validate a web application?
The answer is no. And I love ZAP. It's a very good tool, well put together, but it doesn't test a lot of things which you want to test. First of all, it comes into play at the very end, which is kind of too late. And then it cannot test your business logic. It cannot test some things which are important for you. Yes, you can use that to pre-assess your security, but you have to have formal QA tools or formal QA tests using your red team. So yes, you can use it to some extent, but don't depend totally on it.
Okay, I got 1 minute left. Another question here. Who should be involved in developing security controls? I believe I have a feel that you answered this during the presentation, but go ahead.
I did, and I can emphasize it. I cannot emphasize this enough. Security engineers are the ones which are responsible for security, but the people who really are important are developers along with the actual testers. So those it's a team of what I call purple team: developer who knows the most, engineer who knows the rules, or security engineer who knows the rules, and finally the QA people who know how to test.
Okay, I think the next question is you handled it really very well in the presentation. What role do developers play in testing security in Agile projects?
Making sure that we have an acceptance criteria and the security controls are designed to meet that acceptance criteria. If you don't have proper security control, your system would not be secure. So that and you won't be, you cannot say with high level of confidence that my system is secure.
Okay, since we hit our 10 o'clock here in Pacific time. I want to thank you, everyone. First, I want to thank Bhushan for giving us a time to share his experience with the audience. Thank you so much. I know how busy you are, but thanks for sharing your experience with us. Thanks to everyone who attended today. With that, I'd like to close the webinar by thanking everyone with us today. Thank you all.